Right, here again we're going to solve another quartic equation. It shows that x squared plus 9 is a factor of x to the 4 minus 4x cubed plus 22x squared minus 36x plus 117. Hence, completely solve x to the 4 minus 4x cubed plus 22x squared minus 36x plus 117 is equal to 0. So, if x squared plus 9 is a factor of x to the 4 minus 4x cubed plus 22x squared minus 36x plus 717, then if we use polynomial division, we should have no remainder. If we get a remainder, then we know it's not a factor. Right, so setting up the polynomial division, we're going to do x to the 4 divided by x squared. Now, it's very, very important that you put things in the right column, so as you'll see. So x to the 4 divided by x squared is x squared. So that goes there. Multiplying out x squared times x squared gives me x to the 4. We will put there. We've got no x cubed term, but we've got x squared times 9x, times 9, which is going to give me 9x squared. So notice that goes here, and we leave a space here. Doing the subtraction, we get nothing from here. Minus 4x cubed, take away nothing, is minus 4x cubed. 22x squared minus 9x squared gives me 13x squared. Bring down the minus 36x. So the spaces here are very, very important. We're now going to divide minus 4x cubed by x squared. And that's going to give me minus 4x. Now minus 4x times x squared gives me 4x cubed. Minus 4x times 9 is going to give me minus 36x. Notice again there's a space here. Notice where we put everything. Right, when we do the subtraction, we get nothing from here. We're going to get 13x squared. And again, we're going to get nothing from here. So we'll leave a space. And we'll just bring down the 117. So we're now going to do 13x squared divided by x squared, which is 13. And then multiplying out 13 times x squared goes there. And then 13 times 9 is 117. And we've got no remainder. So as we've got no remainder, x squared plus 9 is a factor. Right. So we've got to solve this equation. X to the 4 plus minus 4x cubed plus 22x squared minus 36x plus 117 is equal to 0. This can be factorized down to x squared plus 9 times this one here, which is x squared minus 4x plus 13 is equal to 0. Writing that out across the top. So we can say either this bracket's equal to 0, so x squared plus 9 is equal to 0, which means that x squared is equal to minus 9. If we take the square root, we get plus or minus the square root of minus 9, which gives me plus or minus the square root of 9 is 3. And then we've still got the root 1, and the square root of root 1 is I, so we get plus or minus 3i. Still a conjugate pair. Or, this quadratic, x squared minus 4x plus 13 is equal to 0. If we first try to factorize, or we use the quadratic formula, this does not factorize, so we're going to have to use that x is equal to minus 4 plus or minus minus 4 squared minus 4 times 1 times 13 over 2 times 1, which gives me 4 plus or minus the square root of 16 minus 52 over 2, which gives me 4 plus or minus the square root of minus 36 over 2. The square root of minus 36 is going to be 6i, using the idea that the square root of minus 1 is I. And then, because 4 and 6 are both divisible by 2, we end up with 2 plus or minus 3i. Writing down the solutions, x is going to be equal to minus 3i, plus 3i, 2 minus 3i, and 2 plus 3i. So this has been a video to show you how to solve a quartic when we have two pairs of complex solutions in conjugate pairs. I hope you've understood, and I thank you very much for watching.